Hello everyone, myself S Falmari. In this video, we are going to discuss the solution of non-homogeneous system of linear equations. Learning outcome: at the end of this session, students will be able to solve the system of non-homogeneous linear equations. Let us consider the first problem. Test for consistency and if possible, solve 2x minus y plus 3z equal to 1, 3x plus 2y plus z equal to 3, x plus 4y plus 5z equal to minus 1. This is the given system and we have to test this system for consistency. If the system is consistent, then we have to find out its solution. First of all, we will write down the given system of equations in terms of the matrix form, like this, where it is the coefficient matrix A, it is the column matrix of unknowns X, and this is the matrix of constants B. Now, for better calculations, we will consider its augmented matrix. The augmented matrix of this system is given like this. Now, we have to apply the row transformation on this augmented matrix in such a way that we must get an echelon form. For better calculations, let us interchange this row number 1 and row number 3. So by changing row number 1 and 3, we get, now you can see this row number 3 is shifted to row number 1, row number 2 as it is, and this row number 1 is shifted to row number 3. This is what the previous matrix. Now we have to apply the row transformations to reduce these two entries to 0. We will use this row number 1 to convert these entries to 0. So we have to perform the row transformations R2 minus 3 R1, and to convert this entry to 0, we perform the transformation R3 minus 2 times R1. So first of all, copying this first row as it is. Now multiplying row number 1 by 3, then we get the entries like this. Now taking simply subtraction of these two rows, what we get? 3 minus 3 is 0, 2 minus of minus, that is plus 12, is 14, 1 minus 15 is minus 14, and 3 minus of minus plus 3 is 6. Performing this transformation R3 minus 2 times R1. So first of all, multiplying this row number 1 by 2, then the entries are like this. Now taking the simple subtraction, 2 minus 2 will be 0, minus 1 minus of minus 8, that is plus 8, that is minus 1 plus 8 could be 7, 3 minus 10 is minus 7, and 1 minus minus plus 2 is 3. So in this way, we have converted these two entries to 0. Now next, we will shift towards the next diagonal entry and will convert the elements lying below of that diagonal to 0. It means now we have to convert this 7 to 0 using this row number 2. To convert this 7 to 0, we have to perform the transformation 2 times R3 minus R2. So writing the first two rows of this augmented matrix as it is. Now multiplying this row number 3 by 2, then we get all these entries. Now taking the subtraction. Obviously first two entries are 0. Now this is minus 14 and minus of minus plus 14, that is also 0, and 6 minus 6 is 0. We have finished the conversion of given augmented matrix to the echelon form. Now this is what the required echelon form. Now once I get the echelon form, to test the consistency, we have to find out the rank of the augmented matrix and the rank of the coefficient matrix. First of all, we are calculating rank of coefficient matrix A. This is what coefficient matrix in all 3 rows, but out of that 3, only 2 non-zero rows are there. So we can say that rank of the matrix A is 2, because the rank of the matrix in echelon form is nothing but the number of non-zero rows. Similarly, this total is the augmented matrix. In this total also, we can see that there were only 2 non-zero rows. Okay, that's why I can say that the rank of the augmented matrix AB is also 2. Now from these two, we can say that rank of A and rank of augmented matrix AB both are same. So according to the condition of consistency, whenever rank of the augmented matrix AB and rank of A are same, we can say that the given system of equation is consistent. It means it has a solution. Now there are two types of solutions, unique and infinite. That solutions are depends upon the relation between the number of unknowns and the rank of the coefficient matrix. If the rank of the coefficient matrix A is exactly equal to the number of unknowns, then the given system has unique solution, and if the rank of the coefficient matrix A is less than the number of unknowns, then the given system has infinite solutions. Let R will denote the rank of A, which is 2, and here n means the number of unknowns. Here in all three variables are given, that's why we can say that n is 3. Now from these two we can say that R is less than n. It means the given system of equations has the infinite solution. Now to find out this infinite solution, we have to choose n minus r unknowns as the parameters. So what is n minus r unknowns here? N is 3, r is 2, the subtraction is 1. It means out of 3 unknowns, one unknown we have to assume or choose as the parameter. To choose one of the unknown out of 3 as a parameter, from this echelon system we have to write down the system of equations. This first row will give us an equation of the type x minus 4y plus 5z equal to minus 1. This second row will give us 14y minus 14z equal to 6. So mostly the parameters we are selecting from the last equation. Now in this last equation you can choose either for y or z as a parameter. Here I am going to choose for z as a parameter t. So now putting the value of z equal to t in this last equation, we'll get the value of y as, this is the equation and we have replaced z by t, and if we solve this we'll get the value of y as 3 by 7 plus t. Now the value of y and z can be substituted in this first equation to get the value of x. So after substituting the value of y and z in this equation, we'll get this new equation, and if we solve this, we'll get the value of x as 5 by 7 minus t. These are the required values of x, y, z. Let us consider one more problem. Test for consistency and if possible, solve. Solution. So first of all, we are writing the given system of equation in terms of the matrix form Ax equal to b, where it is the coefficient matrix A, it is the matrix of unknowns, and it is the matrix of constants. Okay, for simple calculations, we can consider the augmented system of this system, which is given like this. Now, our aim is to convert this augmented system to the echelon form. First of all, let us consider this first diagonal and convert these two entries to 0 using this row number 1. To convert these 2 to 0 using row number 1, we have to perform the transformation R2 minus 2R1. Again, to convert this 4 to 0 using row number 1, we perform the transformation R3 minus 4 times R1. So let us consider the augmented matrix AB, in which the transformations we are applying on R2 and R3. It means row number 1 we have to copy as it is. Now performing this first transformation R2 minus 2 R1, multiplying row number 1 by 2, will get these entries, then subtracting R2 from this. So this is 2 minus 2 0, 1 minus of minus 4 is plus 4, that is 1 plus 4 will be 5, and 1 minus 0 is 1, 1 minus 6 is minus 5, and 4 minus 4 is 0. Now performing this transformation, before that first of all multiplying by 4 to the row number 1, then the entries are like this. Now taking simple subtraction now, 4 minus 4 is 0, minus 3, minus of minus 8 is plus 8, that is 5, 1 minus 0 is 1, 7 minus 12 is minus 5, and 8 minus 8 is 0. I think here we can see that both the rows are identical. So to convert it to 0 is very simple. We have to take simply subtraction of row number 3 and row number 2. So now the augmented matrix AB is, there is no change in the first two rows. Now in the third row, as rows are identical, so obviously the last row will be totally 0. This is the required echelon form. Let us calculate the rank. Now rank of A. In this coefficient matrix A, we have to calculate the non-zero rows. These are the first two are the non-zero rows. That's why we can say that rank of A is 2. And rank of the augmented matrix AB, this is the full matrix we have to consider. In this full also you can see that these first two are the non-zero rows and last one is the 0 row. That's why I can say that rank of augmented matrix AB is also 2. From these two we can say that rank of augmented matrix AB and rank of A both are same. It means the given system is consistent, that is it has a solution. To check which kind of solution is there, we have to compare rank of coefficient matrix A and the number of unknowns. Here R is 2 and number of unknowns are 4. So we can easily say that R is less than N. It means the given system of equation has infinitely many solutions. To find out this infinitely many solutions, we have to select N minus R, that is 4 minus 2, that is 2 unknowns out of 4 unknowns as the parameter. We have to write down the system of equations from this echelon form. It will give us the first equation like this, and second row also gave us one new equation. From the last equation, we are going to select 2 unknowns as the parameters. So first of all, I am going to choose Z as a parameter S1 and T as a parameter S2. After putting the value of Z and T in this equation, get the value of Y, 1 by 5 S1 plus S2. Similarly, putting the value of Y, Z, T in this equation number 1 will get the value of X. After putting all these values, that equation will looks like this, and if we solve this for X, we'll get the value of X as 2 minus 2 by 5 S1 minus S2. So these are the required values of X, Y, Z and T.